SAC 2B, problem 1, is a graphing problem. We're supposed to graph the motion of a car. A car crosses a start line with a velocity of 30 meters per second. The car continues at that speed for 5 seconds. It then accelerates smoothly, obtaining a velocity of 65 meters per second after another 5 seconds. Then the driver applies the brakes and the car slows uniformly to rest in 5 seconds. So it looks like the whole thing takes 15 seconds. So when we label our time axis, we use that. I need a graph of x versus t. Car never backs up, so I won't have to go negative. So this should pretty well work. X, break that up into 3 segments, 5, 10, and 15 seconds. T in seconds, 5, 10, 15, and I'll have X is represented in meters if I need to put any values down. Okay, need a graph of velocity as well. I want to set up the axis for that for now. This car never backs up, so it's never got a negative velocity, so you don't need to go to negative values. Same time intervals. T in units of seconds, and now over here we got V, and we'll consider that to be in units of meters per second. Then the acceleration. Does it slow up? Yeah, the driver applies the brakes, so it does definitely slow up. So we're going to need some negative values of acceleration. So I'll draw the horizontal axis down the middle, across the middle of this vertical axis. Same time axis. T in seconds. Now we've got acceleration in meters per second squared. Alright, I generally find it easiest to start with the velocity and work from there. I'm going to change the color here on you. And let's see, it's already got some velocity. It gets up to 30. I'll break this. Looks like the highest it ever gets is 65, so I'll call that 30, 60 up here. 65 would be about right in there. Starts out at 30 at time 0, 30 meters per second. Continues at that speed for 5 seconds. So that'd be a horizontal line indicating a steady velocity. And a little hard to draw with this tablet, or on this tablet. I'll make another attempt at a straight line, and then we'll just have to call it straight and horizontal. Straight and horizontal over to the 5 second mark. And then car continues with that then accelerates smoothly. The smoothly tells me it's constant acceleration, so velocity versus time will be a straight line, obtaining a velocity of 65 meters per second after 5 seconds. So 5 seconds later, we're up here at 65 meters per second, and we got a straight line extended from there to there. So I'm going to label that S for straight. This is straight as well. And then what happens? Then the driver applies the brakes and the car slows uniformly. Uniformly, once again, that's a constant acceleration. Uniformly to rest in 5 seconds. So right at our 15 second mark, and this one is straight as well. This velocity up here, by the way, was 65 meters per second. Okay. Okay, then another easy graph is the acceleration. Constant velocity means zero acceleration, nothing there. So this is straight line, straight horizontal. This guy was horizontal as well, in case you can't tell. And then we got a positive acceleration for the next 5 seconds. Notice positive slope here on v versus t. The value of acceleration is the slope up here. The slope is the same, one constant value all the way across for that 5 seconds. And you can put those vertical lines in or not as you wish. Okay, this is a straight vertical line. This is straight and horizontal, whether it looks it or not. And that doesn't even look like an H, so let's call that straight and horizontal. There we go. And then we got a negative acceleration. It's a little steeper. In 5 seconds it goes down farther than that one did, so I better go a little more negative over here. Some cases you'll be required to specify key values, and it's at the 10-second mark, that vertical line. I'll drop that one down at the 15-second mark. Another vertical line. Optional. The horizontal components of this graph are the key ones. This is an idealized situation where we're saying the acceleration jumps in 0 time flat from one value to another. In actuality, it could be a very rapid jump, but we're approximated as instantaneous. So this is a vertical line. Here's the negative acceleration. Somebody asked for key values. You could actually calculate it. It goes from 30 to 65. That's an increase of 35 meters per second in 5 seconds. Change in v divided by change in t is the acceleration. So I'd have the 35 meters per second divided by 5 seconds, or 7 meters per second squared. And then over here it would be minus 65 is the change divided by 5, 13, minus 13 meters per second squared. This segment is again straight and horizontal. And we'll leave it at that. I'm not going to label the key values on here. Okay, over here crosses the start line with a velocity of 30 meters per second at the start of observations. So it's already got some slope, continues at that speed, and so we got a straight line. Person, because of that 30 meters per second, they're getting further and further from the start line. I'm just going to label that straight. And then over here we see that the car is speeding up, and I'm going to run off the page if I keep it like that. So I'm going to give this a little bit less slant, setting the scale here a little bit differently. So that's straight, and now I need something that curves up. That is, the velocity is increasing. The value of the velocity is the slope of x versus t. So up here I need something where the slope is increasing. So it's got to be starting off pointing in the same direction, and then as time goes by I got an increased slope. So it's curved up. The whole way it's curved up. Now go ahead and label that as curved up in this region. Alright, it's curved up, and then at the end of that 10 seconds we've got some upward curvature, and now it's going to be curved down, coming to flat. This velocity is 0 at the end of the 15 seconds, so the slope of x versus t has to be 0. So it comes in horizontal, this whole segment is curved flat. Notice no kink here, the slope undergoes no quick change, but it was curving up from there to there, and now it's curving down, and at this point horizontal. H, this is straight and horizontal. Up here, curve down, coming into 0 slant. And that would be our graph of x versus t. And that covers problem number 1 from SAC 2B. Notice we never go down in this direction on the graph. It never comes back toward the axis, because coming down toward the axis would mean the object backed up, and it never backed up. So a little tough to keep things nice and neat with this arrangement of pen and tablet that I got here trying to write on the screen, but in cases where we have trouble with that, we can label the line segments with what we mean. I'm going to use S for straight, H for horizontal, CU is curved up, and CD is curved down. So straight